Okay, so now we're doing single number 5, and this is 5 equations, and uh, utilizing the solubility rules to find out, if they're soluble. So here we have, and we also have to balance them. So here we have CdNO3 in parentheses 2 aqueous plus Na2S aqueous, and that reacts to form CDS solid plus NaNO3 aqueous. So now, first we're gonna balance it, because if we can't balance it, then there's no finding out. So now we're gonna do we're gonna do CD NO NaS. This is a little tight, but it's okay. We'll work with that. So, so on the reactant side, we have one CD, uh, two N's, six O's, because we have the two outside the parentheses, so it multiplies, plus two NA's and one S, and then the CD we have one CD, one S, one NA, and then we have NO3, and then we have one N and three NO. So now looking at this, you can see that the CD is balanced, and the S is balanced. And so we want to change the N for right now. I want to change the N and the O since they're together. So looking at them, we want to change the N's. We want to change the product side, because it's in the parentheses, and you don't really want to mess with the parentheses on the reactant side. So we're gonna go with the product here. So we're gonna put a nice 2 in front of the NaNO3, and that's gonna change the Na to a 2, which it'll balance out, and then that'll change the O to a 6, and then the N to a 2. And look at that, all that is balanced. So now, will this equation work? Uh, yes, they do, because you have the nitrate salt here, and then the alkali. Then you have the alkali metal. So yeah, that'll work quite fine. That'll work, not quite fine, quite nicely. All right. So now we have, this is a big one. And we have K2CrO4 aqueous plus AgNO3 aqueous. That reacts to form KNO3 aqueous plus Ag2CrO4. So now immediately when you look at this, there's a big old red flag, that Ag. Now that Ag, that sort of ruins the equation, and that precipitate will not form, and is just not soluble. But that still leaves us with to balance it. So let's balance it. So we have K C R. I have to do this one pretty small because it's a long list. So AG and then N, because we already have an O. So K, there's 2, CR, we have 1, O, we have 1, 2, 3, 4, 5, 6, 7. Ooh. Then 8, I just put it, it is AG. AG is 1, and we have 1 NO3. And now on the product side, we have 1K, 1K, 1N, and we have NO, and we have seven O's, 1N, two AGs, and then one CR. Ooh, so looking at this here, you first you gotta go from top to bottom here. Whenever you have multiple ones. So now we gotta immediately change the K because it's not balanced. So we're gonna put a 2 on the product side, and that's gonna change the K to a excuse me here. K to a 2. That's gonna change also the N to a 2, and the O to a 6 right here. So now 6 plus the 4 is a 10. So that's gonna be a 10 right there. And yeah. So now that the K is balanced, we're gonna start with the O since that's the next one that's not balanced. So we're gonna go over here and put a nice 2 again because we need it to form 10. So, and that's going to change the AG to a 2. Look at that, and that's going to balance out. And that's going to have the O form a 10 because 2 times 3 is 6, plus the 4 is a 10, and that's going to change the N to a 2. And boom, there is the balanced equation. So now, next one is Na3PO4 aqueous plus CaCl2 aqueous, and that reacts to form NaCl plus Ca3PO4 2 in the parentheses solid. Okay, so now we are going to look at this and we're gonna balance it. So first we have Na, we have P. I'm gonna move it up because we need the space. P O, what is this? A CaCl. CaCl. All right. So we have 3 NAs, 1 P, 4 O's, 2 CLs, and 1 CA. And now on the product side, we have 1 Na, 1 CL, 3 CAs. Ooh, getting a little dicey there. And we have 2 P's and 8 O's because you see that it's in the parentheses there. And 2 is a subscript, so it's going to multiply all that. So now, again, you got to go from top to bottom here. So top to bottom, you're going to change the product side. Ooh, sorry about that notification there. It's talking about Game of Thrones. Ooh, my boy Tyrion. Get it? Yeah. All right. So, we're going to go with the Na right here. We're going to put a nice fat 3, so make the Na even. But that's also going to change the Cl to a 3, and that's going to change that. So now we're going to go to the next one, which is P. We're going to try and balance P. Ooh. We're going to need to balance P there. So we're going to put a 2 in front of the Na3PO4. So that's going to change that to a 6. Ooh, that's going to change that to a 6. And the Na to a 6. And that's going to change the P to a 2 and the O to an 8. Ooh. So now that the Na is unbalanced yet again, we're going to erase the coefficient of 3 that we drew earlier. And we are going to put, now we're going to put a 6. Because now we're hopefully going to balance it out yet again. So that's going to change the Na to a 6. Now it's balanced yet again. And now we're going to change the Cl also to a 6 because it changes the whole compound. So now, see, Na, P, and O are balanced, but Ca and Cl are still unbalanced. So we're going to look at the CaCl. We're going to immediately put a nice 3 there, because it works out pretty well. Look, CA, we're going to change, and then it's going to become a 3. And since there's a subscript of 2 on the CL, it's going to change to a 6. And look at that. It is now all balanced. Okay, so now, see, looking at this, you see the CA, which is not soluble with sulfate salts. But since we don't have sulfate here, it is soluble. So yeah, it is soluble. So now our fourth one, HCl aqueous plus Hg2 NO3 parentheses 2 aqueous. That reacts to form Hg2Cl2 plus HNO3. So let's look at this again. Excuse me. So we're gonna look at this again, and we put HCl, HGNO. Alright, so we have 1 1Cl, 2 HGs, 2 N's, because we have that subscript, and we have the 6 here in the O. So now on the product side, we have 2 HGs, 2 CLs, 1 H, and we have 1 N and 3 O3s. So now, looking at this, we see that the H is balanced. We see that the Cl, though, is unbalanced. So we're going to put a nice 2 in front of the HCl. And that's going to change that to a 2. It's going to change Cl2 to. So now, we're looking at this. Unbalanced. We don't like that. So, H, you see, H you see is unbalanced. So we're gonna put a 2 in front of the HNO3, and we're gonna change the H to a 2, and look at that. Now it balances out. But we're also gonna change the NO3, because remember, it changes the whole compound. So we're going to change the N to a 2 and the O to a 6. And there you go. There you go right there. And now you see that we have Hg right here. We have Hg, which is usually not soluble with sulfate, but yet again, we don't have sulfate salts here. So I believe it is soluble. So now let's go to our last one. We have Na2S aqueous plus ZnNO32. Yeah, there's NO32. Oh, what a guy. NO32 aqueous reacts to form ZnS solid plus NaNO3 aqueous. So, excuse me. So now we're gonna list them, and was it? Yes. Na S Z N N. Oh, look at all the space that we have. Ooh, so much. Really take for granted the amount of space. So now Na we have 2, S we have 1, Zn we have 1, and we have 2 because it's in parentheses. Oh, we have 6, just like the last problem. Now, Na, we have 1 here, and we have NO3, which is 1 and 3, and we have 1Z and 1S. So immediately when you look at this, you just have to change the product side, NaNO3. You just want to change that to a 2, and that'll balance out the Na, the N, and the O. So that's all balanced. Okay, that's all balanced. You can see that this one is also soluble because all the exceptions to the rules are not present. So, so this is single number 5 with all the solubility rules. All right.